Good morning students. Welcome to maths video. In previous video we discussed exercise 8.4 ninth sum. In this video we will discuss exercise 8.4 12th sum. A coin is tossed thrice. Find the probability of getting exactly two heads or at least one tail or two consecutive heads. Three events are given in between the word or also given. So whenever we see the word or, we consider it as union. So we need to find the union for these three unions. So using addition theorem of probability of three events, we are going to find the probability. Now given a coin is tossed thrice. A coin is tossed thrice or three coins are tossed simultaneously. We have the same sample space. Head, 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 tail, head, tail, head, tail, head, head, tail, tail, head, tail, head, tail, head, tail, 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 tail. N of S is equal to 8. The first event is getting exactly two heads. Let A be the event of getting exactly two heads. Then A is equal to, here there are three heads, here two heads. So head, head, tail. Head, tail, head. Two heads are there. Head, tail, head. Tail, head, head. Two heads. Tail, head, head. Tail, tail, head. One head. Here also one head, no heads. So n of A is equal to 3. Then P of A is equal to n of A by n of S, 3 by 8. Then the second event is at least one tail. Let B be the event of getting at least one tail. The meaning of at least one tail is one tail or more than one tail. So one tail, two tails, three tails. So therefore B is equal to head, head, head. So no tail is there. So at least one tail, we must have at least one tail. So head, head, tail. Here one is head is there. Head, tail, head. One tail. Tail, head, head. One tail. Tail, tail, head. So one tail or more than one tail. Two tails are allowed. So tail, tail, head. Tail, head, tail. Two tails. Head, tail, tail. Two tails. Tail, tail, tail. Three tails. So one tail or more than one tail can be there. So n of B is equal to 1, 2, 3, 4, 5, 6, 7. Then this implies P of B, probability of the event B is n of B by n of S. N of B 7, n of S 8. Next, the third event is two consecutive hits. Let C be the event of getting two consecutive hits. Then C is equal to head, head, head. So two consecutive heads are there. So head, 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 tail. So here two consecutive heads are there. Head, tail, head. No consecutive heads. Two heads are there, but it is not consecutive. Two head, tail, head, head. Consecutive heads are there. One head, one head, one head, no heads. So n of c is equal to 3. This implies p of c is equal to n of c by n of s 3 by 8. Now let us find A intersection B. Common elements between A and B. Head, head, tail, common. Then head, tail, head, also common. Head, tail, head. Tail, head, head, also common. Tail, head, head. N of A intersection B is equal to 3. Then P of A intersection B is equal to N of A intersection B by N of S. N of A intersection B 3, N of S 8. Next, let us find B intersection C. Common elements between B and C. Head, head, tail, common. Head, head, tail is common. Tail, head, head, also common. Tail, head, head. That's all. Then N of B intersection C is equal to 2. P of B intersection C is equal to N of B intersection C by N of S. N of B intersection C 2 by N of S 8. Now find C intersection A. Common element between C and A. Head, head, tail is common. Head, head, tail. Tail, head, head. Then N of C intersection A is equal to 2. Then P of C intersection A is equal to N of C intersection A by N of S. N of C intersection A 2, N of S 8. Now common element for these three events A, B, C. A intersection B intersection C. Head, tail, head. Head, tail, head. Head, head, tail, head, head, tail, head, head, tail is common. Then tail, head, head, tail, head, head, tail, head, head. So N of A intersection B intersection C is equal to 2. P of A intersection B intersection C is equal to N of A intersection B intersection C by N of S 2 by 8. Now let us find the union of these three sets A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of C intersection A plus P of A intersection B intersection C. P of A 3 by 8, P of B 7 by 8 plus P of C 3 by 8 minus P of A intersection B 3 by 8 minus P of B intersection C 2 by 8 minus P of C intersection A 2 by 8 plus P of A intersection B intersection C 2 by 8. So plus 2 by 8 minus 2 by 8 getting cancelled, plus 3 by 8 minus 3 by 8 getting cancelled. So remaining 3 numbers are there. So these three numbers, for these 3 numbers denominators are same, then we can add and subtract the numerators. 3 plus 7 minus 2, 10, 10 minus 2, 8, 8 by 8. 8 by 8 is equal to 1. That's all.